Welcome to chemistry class. Haloalkanes and haloarenes part 2. First of all, the methods of preparation. The first method we have already discussed, that is from alcohols. And now the second method, that is from hydrocarbons by using free radical substitution. Which is a simple hydrocarbon, that is methane, isn't it? So if you are adding chlorine to this, in presence of the sunlight, here free radical mechanism is possible. And what about the free radical mechanism? Here chlorine molecule. The chlorine molecule is formed through a sharing of a pair of electrons. Here there is a sharing of pair of electrons. And during homolytic fission, the electrons are shifted equally towards each fragments. And in presence of the sunlight, this produces two fragments, that is chlorine with an electron with excess energy, and they are generally called free radicals. So these are called free radicals. And how many free radicals are obtained there? There is two chlorine free radicals are obtained. And this chlorine free radicals, they are highly reactive species, and that propagate the substitution in methane. So that is a chain continuation reaction. The first reaction, which is called initiation, and the second one, that is chain propagation here. And how the chain propagation? One of the hydrogen is replaced from halogen here. That is, this becomes CH3. One of the hydrogen is replaced by chlorine. And secondly, you can have another possibility, that is by replacing two hydrogens by two chlorines. So that is a di-substituted product. Or you can have replace three hydrogens with three chlorines like this, CHCl3. And what about the fourth possibility? You can remove all the hydrogens by chlorines like this. So the first one is monochloromethane, the second one is dichloromethane, and this is trichloromethane, and this is tetrachloromethane, isn't it? And four possibilities are there. And if a compound which contain only one halogen, that is monohalogen derivative. If it contain two halogens, it is dihalogen derivative, like that. And if a compound contain more than one, they are generally called polyhalogen compounds. So you'll get a mixture of compounds here. And in order to stop the reaction, there is a third stage in free radical mechanism, that is termination. So three stages are involved there. The first one is initiation, that is the formation of the free radical. And the second one is a chain continuation, that is happen here. And thirdly, in order to stop the reaction, there is a termination process. And we can do the same in butane also. And how will you write the structure for a butane here? Here four carbons. How will you complete this? As you can write this as CH3, CH3, because there is n carbons. The middle carbons without branching, you can add H2 there. So this becomes CH3, CH2, CH2, CH3. And when it reacts with the chlorine in presence of sunlight, what are the possible products? What are the possible products? Here there is two types of carbons. Which are they? This is primary, this is primary. What about the middle carbons? Both are secondaries, isn't it? Because this is attached to only one carbon, so that is primary. If it is attached to two other carbons, that is secondary. So two primary carbons and two secondary carbons. So if you are replacing the hydrogen from the primary carbon, you will get one structure. Which is the structure? That is CH3, CH2, CH2, CH2. And if you are replacing the hydrogen from the N carbon, that is chlorine is attached here. And the second case in which the hydrogen is replaced from the secondary carbon, that is CH3, CH2, CH, CH3, and the chlorine is attached to a secondary carbon. So you will get a primary halogen derivative, that is primary alkyl halide, and this is secondary. So two different products are formed. So that is monohalogen derivative. There is possibility for the dihalogen or trihalogen compound also, but we have to study only the monohalogen derivative. So there is two products are formed from butane. Two monohalogen products are obtained. The one is primary and the other one is secondary. So this also follows the same mechanism, that is free radical mechanism. And the next method, that is by electrophilic substitution method, and this method is for the preparation of the haloarenes. And we can try an haloarene, how to prepare the haloarene from toluene. So here this is benzene. If you're adding one methyl group to this become toluene. So this is methyl benzene or toluene, and when it reacts with halogen in presence of catalyst like iron, or you can use anhydrous ferric chloride, or you can use anhydrous aluminum chloride. All are catalysts, and in the absence of light, that means dark, you will get a product. What is meant by electrophilic substitution? What are electrophiles? Electrophiles are electron loving. So they are cations or electron deficient groups. What about electrophiles? They may be cations or electron deficient groups. And here from this X2 it produces an X plus, that is the electrophile here, and this is substituted here in the ring. So where the position of the halogen, that is decided by this CH3 group, and here the CH3 group is an ortho para directing group. This CH3 group is an ortho para directing group. What is meant by that? Ortho para directing group. That is decided by the resonance. This is due to resonance. This is due to resonance. Here this methyl group undergo resonance. There is a resonance effect for the methyl group, and that make the ortho positions and para positions more electron rich. So when we are considering the toluene, due to resonance, this position, and this position, that means this is 1,2 position, this is 1,2 position, and this is 1,4 position, and this is 1,2 position. So there is 2 ortho positions and 1 para position. All are more electron rich than the other positions. So this become more electron rich than other positions, and here there is possibility for the attachment or the substitution of the electrophile. So electrophiles are electron loving. So if these centers are more electron rich, this halogen will be substituted there because this is electron deficient. ഈ വരുന്ന ഇലക്ട്രോഫൈൽസിന് എവിടേക്കാണ് പോകേണ്ടതെന്നാണ് ആരാണ് ഡയറക്റ്റ് ചെയ്യുന്നത്? who will decide the position? That is the group that is already present in the molecule. So the methyl group direct the halogen either towards ortho position or towards para position. So which is the ortho position? That is here or here, and which is the para position? That is opposite to that of this methyl group. So we'll get 2 different possibilities, 2 different products here. The one product in which the halogen is present in the ortho position, that is here CH3, and the halogen is substituted either here or you can substitute that here. And the second possibility, in which the halogen is substituted in the opposite position, that is in the 4th position here, that is para substituted derivative. So this is ortho halogen derivative and this is para halogen derivative. So you will get a mixture of product here. Okay, and instead of halogen, if you are adding chlorine here, so instead of halogen, if you are adding chlorine here, you will get a chlorine substituted product there. Okay, try this. If it react with the chlorine, you will get a chlorine substituted product here, here and here. So this is orthochlorotoluene and this is parachlorotoluene. So what is the name? How will you write the names? This is ortho, chloro, toluene, and this is para, chloro, toluene. Okay, so two different products are obtained from the toluene, that is by electrophilic substitution reaction, and the electrophilic substitution, that is a substitution of the electrophiles in the ring. So we'll get aromatic compound, that is haloarene. And the next method, that is Sandmeier's reaction, that also for the preparation of the aromatic compound. Then that start from aromatic primary amines. Aromatic means that consists one benzene ring here, and if you're adding NH2 to this become a primary amine and also aromatic primary amine. What is the name? This is aniline. And when this compound react with when react with the sodium nitrite NaNO2 and HCl at ice cold temperature, that is between 0 degrees Celsius to 5 degrees Celsius. Since we are adding some ice cubes into the reaction mixture, you will get a product like this, in which the nitrogen of the NO2 group and the nitrogen of the NH2 group, that forms an azo group like this, N double bonded N with chlorine, with here positive charge, here negative charge, or you can write this as, in a combined way, you can write this as N and N joined together forming N2 here and Cl. You can write this like this. And this group, this N double bonded N group, which is the azo group, and the name of this compound is, this is benzene diazonium chloride. This compound become benzene diazonium chloride, and this is a very important compound and is an intermediate for the preparation of many haloarenes. And you can have the some of reactions here. Actually, the reaction is between nitrate and H that forms this NO2 and H that join together forming HNO2 here. That is the nitrous acid. What is the name of this compound? This is nitrous acid. Actually, this is due to the formation of the nitrous acid here, and this group is azo group. Remember that this is azo group, and here this is the name of this compound is benzene diazonium chloride, and this can be easily converted into corresponding haloarenes. How the reaction? See. See the reactions. When this benzene diazonium chloride react with the cuprous chloride, that is Cu2Cl2 or CuCl. You can write this as Cu2Cl2 or CuCl, that is cuprous chloride. Here there is chlorine. This is substituted in the benzene ring by replacing the diazonium chloride group. So that become here the structure. This is benzene. And this N2Cl group, that is an easily replaceable group. This group is an easily replaceable group that can be easily replaced. And the chlorine is substituted there. Here chlorine is substituted. So you will get chlorobenzene there. So if you are treating this with Cu2Br2, cuprous bromide, or CuBr, you will get bromo derivative here. So instead of N2Cl, you can place bromine here. And this is bromobenzene. And when it reacts with or shaking with potassium iodide, and shaking, simply shaking with potassium iodide, you will get iodine derivative, that is iodobenzene. Here iodine is substituted. Here, so three possibilities are there. You can have three possibilities. This is chlorobenzene, bromobenzene, and iodobenzene, and are generally called haloarenes. So this is an easier way for the formation of the haloarenes. And how will you explain the Sandmeier's reaction? is, that is aromatic primary amine. This is NH2 group, that is primary amine. Aromatic primary amine or aniline react with the sodium nitrate and HCl at cold conditions, that is between 0 degrees Celsius to 5 degrees Celsius. First, the benzene disonium chloride is obtained, which when treated with cuprous chloride or cuprous bromide or shaking with potassium iodide, corresponding haloarenes are obtained. So that is explanation for the Sun-Mace reaction. And the next method, that is from alkanes by using hydrohalogenation method. So how will you carry it, the reaction on alkene? Which is the simplest alkene? You can take a simplest alkene by taking carbon-carbon double bond. So how will you complete this? This carbon forms only two bonds. So it can form two more bonds with two hydrogens. Here it forms only two bonds, so can form bonds with two hydrogens. So what is the structure? That is CH2 double bond CH2. And if you are adding a hydrogen halide, what is meant by hydrogen halide here? It may be HCl or HBr or HI. So if you are taking HCl here, that is hydrogen and halogen. So addition of hydrogen and halogen, which is called hydrohalogenation. So what will happen here? Here the breaking. So here H plus and Cl minus. And here due to the pi bond, that is a weak bond, there is breaking. And what will happen? The hydrogen is attached to one of the carbon and chlorine is attached to the second carbon by breaking this bond. So what is the product obtained there? That is CH2, the double bond becomes single bonded. CH2, what about the hydrogen? This hydrogen and this hydrogen join together forming that big CH3. And what about CH2 to the CH2, the chlorine is attached. So you'll get the structure like this. What is the name of the compound? This is chloroethane. Chloroethane, isn't it? What is the name of this one? This is chloroethane. So if you're starting with a 3 carbon member, how will you write the structure? You put 3 carbons like this. And you can add one double bond here. Here or here, anywhere you can give. And how will you complete this? This become equal to CH3. Here 1, 2, 3. So you have to add one hydrogen there. 2 already, so 2 more. So structure will be like this. So instead of HCl, you can add HBr here. Then what is the product obtained? So you have to remember a term here. This is a symmetrical alkene or this is symmetric. What is meant by symmetric? Both the ends are same. That means around the carbon-carbon double bond, the groups are similar. What about this? This is an unsymmetric alkene. So when an unsymmetrical alkene is added to an unsymmetrical reagent, you have to remember a rule. What is the rule? That is Markovnikov's rule. So what is the rule? If there is a negative part here, this is positive part. According to the rule, the negative part of the addendum is added to the carbon with the lesser number of hydrogens. Where the lesser number of hydrogen? Here the lesser number of hydrogen. The negative part is added to the carbon with the lesser number of hydrogen and the positive part to this group with high number of carbons. Okay. And what about the product here? This is the major product, that is CH3, and to CH the bromine is attached. Here the bromine, and to CH2 the hydrogen, so that becomes CH3. Okay, so that is CH3, CH, Br, CH3. Okay, this is the product. So what is the name of the product? That is 2-bromo. How many carbons are there? 1, 2, 3. So that is propane. 2-bromopropane. So this is the major product. This is major product. So there is the minor product also, that is in minor quantities, that is the reverse product. So instead of this, you can write the minor product also. That means the reverse addition, that is bromine is attached here. So instead of that, the bromine is attached here. That means that becomes CH2Br. And what about H? H that is attached to CH. So H2 here. That is a second possibility. That is, you can write the structure like this. That is CH3, CH2, CH2. The bromine is attached here. That is to the first carbon. And what about the name? That is 1-bromopropane. This is 1-bromopropane. What about this? This is the minor product. Okay, so this is Markovnikov's rule. Then what is Markovnikov's rule? What is Markovnikov's rule? Okay, here when an unsymmetrical reagent is added to an unsymmetrical alkane, when an unsymmetrical reagent is added to an unsymmetrical alkane, the negative part of the addendum is added to carbon with the lesser number of hydrogen atoms. And if the reaction is carried out in presence of peroxides, the reverse product is obtained. That is, the product formed is against the Markovnikov's rule, and the rule is called, and the effect is called peroxide effect or Karash effect. So, what is meant by Karash effect? When the hydrohalogenation is carried out in presence of peroxides, the product formed is against the Markovnikov's rule. Effect is called Karash effect or peroxide effect. That is here you can have the equation like this. So if the reaction is carried out in presence of peroxides, the reverse product is obtained there. That means this become the minor product and this become the major product. So here it become minor product, that is the reverse of the product that is based on Markovnikov's rule, and this become the major product. See here, this is the Karash effect. Okay. Then the last method, that is from alkanes by the addition of halogens. So which is the simplest alkane? We can start with the simplest alkane, which is the alkane that is CH2, that is ethane. So when halogens are added to this, for example, if you are adding chlorine to this in presence of CCl4, chlorine in CCl4, what is the product obtained? Here two chlorines and here also weak point, or there is a weak bond that will undergo, that will break, and one of the chlorine, here two chlorines are there, here two chlorines, and one of the chlorine is attached to the first carbon and the second chlorine to the second carbon. So you'll get the product like this. CH2, this becomes single bonded CH2. And what about the position of the chlorine? One chlorine is attached here and the second chlorine here. And if the chlorine atoms are in the adjacent positions, they are called vicinal dihalides. They are generally known as vicinal dihalides. That means if they are in adjacent positions. Here it is 1, 2 positions. And what is the name of this compound? This is, how will you number this? This is 1 and this is 2, isn't it? So how will you name this? This is 1, 2 dichloro plus ane, that is ethane. Okay, this is 1, 2 dichloroethane. And if the same is carried out in presence of bromine in CCl4, for example, you can take a 3 carbon member. You put 3 carbons in straight chain, put a double bond here. This will be equivalent to CH2, CH. Here it is CH3. Then you can add bromine. Instead of chlorine, you can add bromine here, bromine in CCl4. Bromine in CCl4, what is the color of the bromine? That is a brown colored liquid. This is brown in color. And when it reacts together, what will happen? Is here the breaking. This will break, that is the pi bond. And what is the product obtained there? Is here it is CH3, here CH, and one of the bromine is attached here, and this becomes CH single bonded CH2, and the two bromines are attached here. So what is the name of the product? Is this is, how will you number this? This is 1, this is 2, and this is 3, isn't it? How will you name this? That is 1, 2 dibromo is a 3 carbon member, that is prop plus ane, that is propane. That is 1, 2 dibromo propane, isn't it? And what is the speciality of this reaction? Here this bromine water is bromine in CCl4, that is brown in color, and after the reaction this become colorless. So this is a visible test to identify the presence of double bonds or triple bonds. So if there is double bond or triple bond, or if there is presence of unsaturation, then only the solution become colorless. If there is addition, then only there is color change. So this test is used to identify the presence of double bonds or triple bonds. Okay. Now we have 6 methods for the preparation of aromatic halogens and haloalkanes. 6 methods ആണ് നമ്മളിവിടെ ഡിസ്കസ് ചെയ്തത്. ഇതിനെ ബേസ് ചെയ്തുകൊണ്ട് നമുക്ക് കുറച്ച് ക്വസ്റ്റ്യൻസും കൂടെ നോക്കാം. Here the first question, that is identify the products. First question നമ്മൾ കൊടുത്തിരിക്കുന്നത് hexagonal ആയിട്ടുള്ള റിംഗ് ഉണ്ട് with OH. What is the name of this compound? This is not benzene with OH. This is not phenol. This is cyclohexanol, isn't it? Cyclohexanol, isn't it? So when it reacts with SOCl2, so this is the first method for the preparation of the haloalkanes, that is from alcohols. This compound contain OH. So how will you prepare the corresponding product? Here there is chlorine. So this OH is replaced by chlorine here. So this is substituted here. So what is the product obtained there? You can write the product like this. The cyclohexane, instead of OH, here this chlorine. So this is A. So how will you name this compound? And what is the byproduct obtained? First of all, what is the byproduct? Is with the sulfur, with the thionyl chloride. This is SOCl2 is thionyl chloride. With this, what are the byproducts? The one byproduct, that is SO2, and the other one is HCl. Both are gases. This is gas and this is gas. It can be easily eliminated. So how will you name this compound? This is hex plus A. What about the term? This involves cyclo. And there is one substituent, that is the first position. So you can add 1 chloro cyclohexane, isn't it? Or you can add simply chlorocyclohexane, isn't it? That is the name of this compound. And what about the second one? Here the second one, the second question, this is the first one. Identify the B. How will you identify this? Here there is addition of the hydrogen and iodine. So there is splitting like this. So this is hydrohalogenation, and this is an alkene, isn't it? This is a cyclic alkene. Here the double bond. So addition takes place in between these carbon and carbon. So here the breaking. And with the addition, here you have to remember the Markovnikov's rule. This is based on Markovnikov's rule. The negative part of the addendum is added to carbon with a lesser number of hydrogen. Which is the carbon with a lesser number of hydrogen? Here there is a substituent. So this is the one with the lesser number of hydrogens. So here there is a bond between carbon and CH3. Here there is no bonding. So this group is CH, here C. Okay, so which is the carbon with the lesser number of hydrogen? That is this carbon that is attached to CH3. Okay, so how will you write the product there? You can write the product like this. Here already CH3. To that this iodine also. So the iodine is added to the same carbon. And what about here? Here the hydrogen, so no need to write anything there. So here the hydrogen, so that becomes CH2 here. So here the double bond will break. So this is the product. So how will you name this? There is 2 substituents which is attached to the same carbon. That is the first carbon. You can take this as first carbon. And the 2 substituents, iodo and methyl group. So how will you name this? You have to consider their alphabetical order also. So that is 1 iodo, 1 methyl. You have to add a hyphen here, cyclohexane. Okay, so that is a name, that is B, this is B, and this is A. And what about the C and D? So there is addition of HBr, and here also the same, that is halogenation, hydrohalogenation is there, hydrogen and halogen, the same type of addition is there. Here the breaking, and here the double bond. So where the addition, that is based on Marconi's rule. So the negative part is added to the carbon with a lesser number of hydrogen, and the hydrogen to here, and you will get the product like this. So which is the major product? That is C. So you have to write the major product first. That is no change for this part. That is as such. And here you can give the grouping CH2, CH, to that the bromine. Here the bromine. And here this becomes single bonded. And here it becomes CH3. Okay. Plus, that is a major product, so that is C, and there is minor product also, that is, the minor product is the benzene here, and here CH2, here CH plus H, then becomes CH2, then CH2, and here the bromine. Okay, so that is D. So this is C and this is D. And the last one, you have to find out E. How will you find out E here? Yes, this is an alcohol. Again, OH is the replaceable group. So chlorine is substituted here. Here chlorine is substituted. There is a halogenating agent. So what is the product obtained there? That is CH3. See this part, no change. Here CH3. Here CH3. And OH is replaced by chlorine. So this becomes chlorine. Chlorine is substituted here. Plus the byproduct. If it is PCl3, what is the byproduct? That is H3PO3. Okay. So this is the product formed. We have to identify A, B, C, D and E. So നമുക്ക് എങ്ങനെയാണ് ഇത് ഐഡന്റിഫൈ ചെയ്യുന്നത് മനസ്സിലായിട്ടുണ്ടാവും. സോ ഇതുപോലെയുള്ള പ്രോബ്ലംസ് നമുക്ക് ഇത്തരത്തിൽ ഈ ടോപ്പിക് പഠിച്ചാൽ നമുക്ക് ആൻസർ ചെയ്യാൻ പറ്റും. സോ ഇന്നത്തെ നമ്മുടെ ക്ലാസ് ഇവിടെ അവസാനിക്കുകയാണ്. വീണ്ടും ഇതിൻ്റെ ബാക്കി ഭാഗവുമായിട്ട് നമുക്ക് കാണാം. ഓക്കെ, ബൈ.